Okay, I think it's recording. So, exercise 5C2, question 6, this one here. We've chosen this because it's near the end. I thought I'd do 6 and 7. 7's a nice one because there's two different functions. So that one's a bit more complicated. This one uses trigonometry or uses the sine function. Maybe that makes it a bit more interesting. So we've got a velocity function with a sign in it, which is telling us the velocity of a cyclist in kilometers per hour. And then it says sketch the graph. Okay. So what was it? Kilometers per hour. That would make sense for a cyclist. I need my pen. There we go. Kilometers per hour. Okay, so the principal axis is 20, the amplitude's 5, the period, maybe not so sure about that. Period for a sine wave is 2 pi on b, where the b value here is a 10. So we get 1/5 pi, we're going to get 2 pi on 10. So it's going to be roughly, what, 0.6-ish? 1/5 of pi. And they want us to sketch, they set up to 2. 0 to 2. So I'm just thinking, if one of these curves, what is 1/5 pi? I'm going to go to the calculator and find out. You get one cycle of a sine wave. There's another one. That is a different question though. Just clear everything. So if I had 1/5 of pi, or take pi and divide it by 5, it's about 0.6. How many of those will I fit into 2? I've got a graph from 0 to 2. A bit over 3 sine waves. 3.2 sine waves? This would probably be a good one to actually use technology for. So let's change this. We had 20 plus, now it was 5 sine of x, or t, sorry, 10x, 10t. That's right. Now with the viewing window, they want me to go out to 2. Let's go from minus point, I don't know, maybe just go slightly bigger than 2, 2.1. I know the principal axis was 20, amplitude's 5. I'm going to need to see up to maybe 26. And maybe I'll go all the way down to the x-axis. So I'll set my y minimum at -1. If I graph that, so there's our velocity, and principal axis is at y equals 20, which I think is a good idea to put on when you're sketching. 20. So I could show it here. I like to draw that in. What's the scale here? I'm going to change that to maybe 0.5. Then we'll see where our 2 is. So that's a half, that's 1, 1.5, 2. So I've got to stop my sketch just before it gets to the maximum. I wonder if it shows you. So if x is 2, we're before the maximum, right? Just before the next maximum. Okay. Yeah, just before the 25. Okay. So, a way you could do this is to do your sketch and then put your 2 in at the end. Right, or you could sketch in terms of, maybe we'll do that. We'll do 1/5 pi, 2/5 pi, 3/5 pi. Okay, so have I got pen? No. I need pen. Remember, we don't need to worry about negative time. Time in hours. Velocity is in kilometers per hour. Okay, we need to go up and then draw a principal axis in where the velocity was 20. That's because this sine wave has been lifted up by 20, which I can see here. Right. I can also see that sines always lie between -1 and 1, but these sine values have then been times by 5. So they're going to go up 5 and down 5. That'll be 25. That's where our maximums will be. And our minimums will be 20 minus 5 will be 15. I've got to fit in 3 waves and a bit. So the way I might do this is, maybe if I pick a point here, I'll say that can be 3 periods worth. Then I'll try and break this up into thirds nicely. So that'll be 1/5 pi, 2/5 pi. It's because I've worked out my period length. So I've got to go do one of them. Oh, I am not good at sketching. Now I've got to do another one. It's even worse than me drawing on the whiteboard because this pen's a bit dodgy. And then we come up to our 3/5 pi, and then we want to go up, but not quite to the next maximum, and draw a little arrow just to indicate that this will continue. So that's happening at about 2. You know, it's just a sketch, right? And that would be enough. Maybe, yeah, we've got everything shown there. All right. If we're working out distance and displacement, velocity is always positive. It's just going up and down between 15 and 25. Distance and displacement will be the same. There's no point where the cyclist reverses direction and does negative velocity. You've got to imagine, it's a bit artificial, but you're imagining the cyclist is going along a straight road in the same direction. So he's moving to the right, or he's moving forwards. Maybe that's one way to think about it, because you're not going to think about all the angles that the cyclist is changing when he's turning corners. You're just thinking about him going forward, or her. He's not stopping, turning around and going backward. That would be negative velocity. So that's what we're trying to model here. I assume that they're going to ask about displacement and velocity. So when we find the velocity after 0.575, find the total distance after 2 hours, which will be the same as the displacement, right? Because it's always positive. So I might jump to C, part C first. This is question 6, wasn't it? They want total distance. And I can get that simply by doing the integral. Right, so I just need the integral of the velocity from 0 to 2. The velocity function was 20 plus 5 sine 10 t. We're integrating the whole function. So that will equal 20t. Keep your constant, 5, Now, the derivative of cos is minus sine. So the integral of sine is minus cos. So you're going to be timesing by minus cos. That looks dodgy. Keep this the same. It's application of the chain rule, I guess. Then if I was taking a derivative, I would at this point be multiplying by 10, looking at the inside function where the t is multiplied by 10. So we multiply a derivative by 10, but I'm not. I'm doing an integral, so I've got to do the opposite and divide by 10 to deal with the inside. And that all needs to be evaluated between 0 and 2. Tidying this up, I've got 20t. Oop, pen stuffed up. Oh, it's not plus, it's minus. Minus 1/2 cos 10t. Right. Square brackets to show that we're going to plug in 2 and we're going to plug in 0. So we're going to get 20 times 2 minus half of cos. Now when you put the 2 in, it'll be cos 20. Make sure you're in radians. Then you're going to do minus. You're going to put 0 in, so that's easy. 20 times 0 is 0 minus half of cos 0. And remember, cos 0 is not 0 like sine. If I've got a little unit circle, cos of 0 is in here, where the unit circle starts. Yeah. So that's 1. So there'll be minus 1/2 times 1. That's minus 1/2. You're going to get minus 1/2. That'll be plus 1/2 at the end. This bit here I'll need a calculator for. So it ends up being 40 minus half cos 20 plus 1/2. Right? And I'm guessing the cos 20 won't be that big of a number. So I'd be assuming that this would come out to be about 40. But if I go here, this is just going to be a mess now. So how am I going to remember that? 40 minus half cos 20. 40 minus half cos 20. All right. And then we have to plus 1/2 on the end. We get 40.3-ish. And while I was doing that, I was checking up here that my calculator was in radians. But year 12, I think most of the time it will be. Now, if this question was only worth, a couple of marks, that was probably a good indication that I could have just used the integral. The velocity function, can you remember it? I think it was 20 plus 5 sine 10x. And again, another reminder that if you're using the integral, you want to put your velocity in, not the antiderivative, which you've worked out. And now I should be getting the same number here. Yep. Sometimes the decimals can be slightly different. But there you go. Right. So it was 40.3 kilometers if we quote to 3 significant figures. Right. Well, that's right. I deleted everything. Find the cyclist velocity after 0.5 hours and 75 minutes. That's just a substitution. We've got our velocity function. We're just going to so we're just using 0.5 as our t value. Right, so here we're doing 20 plus 5 sine 10 times 0.5, which is 5. I'm finding out what the number is. It'll be between 15 and 25. 75 minutes, be a bit more careful. Right, so that's the velocity at 0.5 hours. Here, the velocity at 75 minutes. So that's an hour and 15 minutes. And 15 minutes is a quarter of an hour, so you need to be doing 1.25 or 1 1/4, same thing. So you're going to have 20 plus 5 times sine of 10 times 1 1/4, which will be 12.5. Right, so just watch the units. And I think that covers everything for that question. Okay, good.